Good morning
Can we
and
start?
good evening to all. Dear Honorable Speaker, research enthusiasts, participants, welcome to our most expected research idea series. I am Salman Fazle Rabby, core team member of 𝒒₂𝒂𝒓𝒕 platform. I am currently working as a lecturer in Sylhet Engineering College from Bangladesh. It's my pleasure to host today's program. Before diving into the live session, I would like to introduce 𝒒₂𝒂𝒓𝒕 𝑣𝒐𝒂𝒂𝒏 platform, its mission, vision, and activities. 𝒒₂𒂂𝒂𝒓𝒕 or 𝑣𝒐𝒂𝒂𝒏 is an online-based or non-profit open platform directed by some world-class scholars. They are tirelessly working to promote research and guide young researchers in Bangladesh. Its vision is to leverage research in higher educational institutes for sustainable development all over the world. Its noble effort has been initiated by Mr. Mohammad Sabir Hossain. He is currently working as professor at Department of Computer Science and Engineering of Chittagong University of Engineering and Technology, Bangladesh. However, we know that universities are going in the traditional way, although universities are supposed to be a place for knowledge creation and dissemination. The final year students do their project and thesis for obtaining the certificate, but research and publication at undergraduate level are rare. Mr. Sabir Hossain worked in a different way. By his effort, the second year students of CSE Department of CUET have published more than 10 articles in international conference and journal. This type of accomplishment is rare not only in Bangladesh but also in first world universities. Being perplexed by this achievement, he has created his platform to diverge this enthusiasm among all you students who are interested in higher studies. The platform assists researchers by sharing research-related resources such as books, paper, website, etc., conducting various training courses, arranging seminars, workshops, or webinars, research collaboration, supervision, etc. Previously, they have conducted the country's first free, complete online training on how to become a researcher. This course covers the basic concept, tools, and techniques required to become a researcher from zero knowledge. The recorded lectures on YouTube received more than 30,000 views within 10 months only. They have started the most demanding online course also known as Python for Research from any discipline on 31st April this year. Research Idea Series, what is this and why? We know that selecting research ideas is the most important step in research methodology. However, finding a research idea topic is a challenging job for the research enthusiasts and new learners. To assist them in finding the ideas easily, we are organizing this research idea series. Research scholars from home and abroad of different disciplines will deliver lectures related to his research expertise or domain of knowledge. Basically, speakers will share trending research topics, skills, tools, and techniques required to start his current and past research projects, publication guidelines for a specific field. We have a plan to cover all possible research areas in future. About today's lecture topic is energy efficiency in smart buildings through IoT sensor integration. IoT, or in short, in abbreviated as Internet of Things, deployments offer a much higher value proposition in this can function in this context of smart buildings. Such advanced information and communication technology is applied in commercial buildings, schools, libraries, shopping centers, etc., which offers low cost but highly effective monitoring and control opportunities. Sensor deployment Sensors deployed in key locations can monitor the building environment in real time, collect information for intelligent decision making, and facilitate various services. An IoT sensor platform has been developed that provides a unified communication platform which can integrate information from disparate sources and provide one control hierarchy. It is a powerful, low-cost, open architecture software platform that can monitor and control major electrical loads such as HVAC, lighting, and plug loads, as well as solar PV system, energy storage units, and other IoT sensors in commercial buildings. The platform can provide new and legacy buildings within a building automation system (BAS) or connect with existing BAS system in large and small commercial buildings. This platform leverages machine learning algorithms to draw insights from a deployed building's historical operating data and occupant preferences to save energy while increasing occupant comfort. This also allows building to produce peak demand through direct communication with utilities using demand response protocols such as Omen ADR. About today's honorable speaker. Today's honorable speaker is Professor Saifur Rahman. Professor Saifur Rahman is the founding director of Advanced Research Institute at Virginia Tech, USA, where he is the Joseph R. Loring Professor of Electrical and Computer Engineering. He also directs the Center for Energy and the Global Environment. He is a Life Fellow of the IEEE and IEEE Millennium Medal winner. He was the president of IEEE Power and Energy Society for 2018 and 2019. He was the founding editor-in-chief of IEEE Electrification magazine and the IEEE Transactions on Sustainable Energy. He has published over 150 journal papers and has made over 500 conference and invited presentations. In 2006, he served on IEEE Board of Directors as the Vice President for Publication. He is a distinguished lecturer for the IEEE Power and Energy Society and has lectured on renewable energy, energy efficiency, smart grid, energy internet, blockchain, IoT sensor, etc. in over 30 countries. He is the founder of BEM Control LLC, a Virginia-based software company providing building energy management solution. He served as the chair of the U.S. National Science Foundation Advisory Committee for International Science and Engineering. He has conducted several energy efficiency blockchain and sensor integration projects for Duke Energy, Tokyo Electric Power Company, the U.S. National Science Foundation, the U.S. Department of Defense, the U.S. Department of Energy, and the state of Virginia. He has a PhD in electrical engineering from Virginia Tech. The lecture will start now. There will be a question answering session after the lecture. You can ask your questions by commenting on this live program on our page. Now, I am requesting our honorable speaker to take the floor. Dear audience, Professor Saifur Rahman. Sir, please.
Thank you, Salman. Good day, everybody. I'm very happy to be able to come in front of you to talk about one of my research projects. This one deals with energy efficiency in smart buildings through IoT sensor integration. And Salman has just given you a good layout of what I'm going to talk about. So let's move on. First of all, what is the purpose and objective for this research? Focusing now US market, in the US, buildings consume over 40% of total energy in the country. Total, not just electricity, gas, oil, nuclear, all that, 40% goes to buildings. In the US, there are over 6 million buildings. 90% of those 6 million buildings are small or medium size, or smaller size, under 5,000 square feet. Medium size, between 5,000 and 50,000 square feet. These buildings are small. They cannot afford expensive building automation systems, which are available for large buildings. Therefore, these buildings don't do any control. They just let the building do what it wants to do. We built a platform called WISE Building Platform that facilitates energy efficiency applications in commercial buildings using simple and scalable building automation system. Why do I say scalable? You can start with just one floor in your building, or maybe just one thermostat, maybe a couple of plugs. Apply this WISE Building Platform, run it. As you get comfortable, you can then expand that to other parts of the building. That's why I call it scalable. So what is this? WISE Building is a building energy management open architecture software, open architecture, which is engineered to improve sensing and control of all IoT-enabled equipment in commercial buildings. What's an IoT equipment, IoT-enabled equipment? thermostats, control heating and cooling, smart switch, smart plug, light controls, rooftop solar, battery storage, all of that. If you want to know more, I have given you on the upper right-hand side a website called bmos.org. If you go to that website, bmos.org, you'll see multiple opportunities that you can learn from. I have also put part of my some of my papers on that website. Learn more. Anyway, what we have done, 3 major building loads I just mentioned: heating, ventilation, air conditioning, lighting, and plug loads. This also improves energy efficiency and facilitates peak load savings in buildings. So what is it? Well, this is my lab setup. I say here, WISE Building supports multiple IoT devices through industry standard protocols and communication technologies. In the middle, I have the oval shape diagram. I have on the upper left-hand side different types of thermostats in my building, some Wi-Fi, some Zigbee, and so on. Then I have VAV controller, which is controlling the airflow in the building, RTU, rooftop units, different kinds of lights. I have light switch, lighting load controller, step dim ballast for your tube lights, smart plug, different kinds of smart plug. One is Wi-Fi, one is Zigbee, plug load controller, backnet. Backnet and Modbus are 2 protocols which are wired. Wi-Fi, Zigbee, as you know, are wireless. Also, I have occupancy sensor. You can see on the upper right-hand side, light sensor, power meter, and so on. Also, in the middle of the page, I have like the gray plastic box. That box contains a Raspberry Pi. That's my controller. Raspberry Pi collects wireless information from all these devices. Algorithm that I have built, WISE Building, sits on the Raspberry Pi, and depending on what you want to do, change the temperature, change the timing, change the heat setup, cool setup, it can do the job. Raspberry Pi is just a card, right? You have to provide I/O devices. I'm using an iPad for my iPhone for my I/O device application. This is the building on the left-hand side. I'm giving you this layout in 1 floor, 1 lab. The building is 6-7 stories. Once you start with the lab, you can expand it to the whole floor and then to the whole building. As you expand the size of your deployment from 15 devices here to 150 devices, 150, 10 times, Raspberry Pi not enough for you. What we have done for those cases, we have moved to the cloud. Now, in lieu of Raspberry Pi collecting information from all these devices, we have put a gateway in the building. The gateway collects data from all those IoT devices, sends it to the cloud. Cloud has the algorithm. It does the processing and sends command back what to do. Dim the light, turn the light off, turn the smart plug off, or change the temperature, change the fan operation, all of that. That's how it's done. Now, as you can tell, well, in this picture I'm showing you, I'm using all commercial devices. Commercial, I don't build any device. Every company who produces the meter, the plug, the smart switch has their own protocol, which they feel efficient for their applications. I have different technologies: Ethernet, serial interface, Zigbee, Wi-Fi, data exchange protocols, backnet, Modbus, web like JSON, XML, Zigbee, smart energy profile, OpenADR. All that is okay for me. On the right-hand side of the screen, I've given you their logos. Maybe you know some of these yourself. The point I'm trying to make is our contribution has been we are able to receive information in different medium, get the data, run the algorithm, send information back using the same protocol they are designing their system with. That's our contribution. Now, there was 1 floor, one building. Now, this is a campus application. Like Chuet campus has many buildings. So how do you manage this? In this case, you see, I have the cloud in the middle of the page, which has, the cloud has many many space, which is a cloud-based space, server-based space for each building. Every building has, like on the right-hand side, heating, ventilation, air conditioning, lighting load, plug load, sensor or power meters, water meters, rooftop solar, storage, security camera. Every building has that. So each building has an account in the cloud. I use Amazon Web Services, AWS. So multiple buildings have many accounts. The campus manager can see the data for every building. They can send campus-wide command about controlling building operation. So this is the operation. So every building has something. It has an account in the cloud. The master controller is with the campus manager. They also connect to the power company on the upper left-hand side. Because power company's power price may change, they may send some signal to reduce consumption. All that is possible using this layout. Okay, now, that means we can now claim that this WISE building platform can make an old building smart. If you want to know more, we have WISE building, WISEBLDG app on both Google and Apple OS. So you can look at that WISE building, download it, and play with it. Now, some examples of what we have done besides the control. We have done many applications in Virginia and Washington, D.C. areas. We have found, on the average, our WISE building protocol, when deployed in a building, can give us about 20% savings of electricity for heating, cooling applications, and 25% efficiency or energy savings for lighting applications. I'll give you examples in a few minutes. So what it also does, because of this automated data collection, it provides improved operations and maintenance so that we know something fails before it fails. We know it and take corrective action. Other is very interesting, occupant satisfaction. In addition to controlling temperature or light switch and all that, we also measure carbon dioxide concentration, PM 2.5 concentration. Based on that data, we can send extra amount of fresh air so that the CO2 concentration does not go very high and make it unhealthy. Those are the added benefits of this WISE building protocol. Now, we have deployed our solution in many buildings, just 4 buildings on the screen here, 3 in Virginia, 1 in Maryland. That's fine. This is a building in Virginia, classroom building. As I said before, WISE building can make an old building smart. That means we are not limited to only new buildings. Since we are all using wireless applications, go to any old building, doesn't matter. Replace the thermostat, replace the light switch, replace the plug, and we are in business. I'll give you an example of this case before. This building was built in 1947, so 75 years ago almost. We can still use this technology in an old building. Now, this is one classroom in that building you just saw. The classroom has many chairs, people come to class, and that professor's desk and all that. We want to monitor this classroom and see how we can make the classroom more energy efficient and more healthy. So we have deployed on the upper right-hand side a sensor to monitor CO2, noise, temperature, relative humidity. One sensor, wireless. Then below that on the right-hand side, I have a BMOS code. That's my computer to collect information from various parts of the building. BMOS stands for Building Energy Management, open source software. It's like a Raspberry Pi. Below that on the right-hand side, I have a plug load, smart plug. Then I have on the left-hand side, motion sensor, thermostat, and the power meter, which is measuring power consumption for the air conditioning unit in the roof. So why do I need a plug load controller? You can see this room has a computer, ceiling mounted LCD projector, and a printer. What this plug load controller does, after classes are over, people forget to turn these things off. So it has been programmed to turn things off after half an hour after classes end, 9:30 p.m. It's not on over the weekend. Next morning, Monday, it comes back. That is saving energy as well. Now, this is a screenshot of the I/O for this application in their classroom. You can see indoor temperature, humidity, pressure, CO2 concentration, noise, all on one screen. Then on the right-hand side, you see the outdoor conditions, temperature, humidity, and all that. And the lower right-hand side, I give you an inset, which is the CO2 concentration data. Very interesting. As people come to class or come to the floor about 5 o'clock, CO2 level stays about 500 parts per million. That's ambient. Slowly goes up to about 600. By the time class starts at 7 o'clock or so, it has gone to about 700 parts per million. Still not bad. But then, as people sit down, they are in the classroom, no windows, they breathe, of course. So CO2 level goes up, goes as high as 1,100 parts per million. Big number. What does it mean? If and when in any enclosed space, CO2 level goes more than 700 parts per million, you begin to feel uncomfortable, feel dizzy, feel a headache, lack of energy. You feel that in a classroom. You don't know why you're feeling this. We have a solution for you. We know CO2 level has gone up. Therefore, what we do, in this case, when the CO2 level goes over 700 parts per million, we throw more fresh air in the classroom. Dilutes the CO2, you're fine. That's an example of how we can make a building more healthy. Then the data for energy savings, 2 parts on this picture. In the middle part, a gray box up and down, and the right-hand side, yellow box up and down. The gray box shows temperature profile before we do any control, no control, right? So you see 3 lines. Blue represents the power consumption by the air conditioner. Green represents the temperature, and red represents the set point for the thermostat. Set point about 74 degrees, right? We have in the beginning at 1 o'clock, AC was not running, so temperature slowly goes up. You can see the step increase in the green lines. When the temperature goes more than 2 degrees above the limit of 74, the Fahrenheit, by the way, AC comes on. It stays on for 5 minutes, cools the room, temperature drops, it goes below 74, maybe 72, and stays off for 5 minutes or so till the temperature goes up again and the AC comes on. Normal practice. In this case, we set point 74 degrees Fahrenheit, about 22 degrees Celsius. Energy usage in the 4 hours between 1 p.m. and 5 p.m. was 2.72 kilowatt-hour. It's normal for one air conditioner. Peak demand was 3.98, almost 4 kilowatts. No intervention. On the right-hand side of the screen, I have the yellow box, temperature profile after wise building deployment. We raised the set point from 22 to 23 to 25 degrees centigrade, 77 Fahrenheit. Because of the control, we did not turn the compressor on for 4 hours. And then temperature starts at about 21 degrees. You can see on the right-hand side, the green line. No AC running, so the temperature slowly increases. At 5 o'clock, it's 77, which is too high. We turn the AC back on. That's it. But net result is we have used during the peak hour 1 to 5 p.m., 1.4 kilowatt-hour, half of what you had before. The max demand was only half a kilowatt, not 4 kilowatts. Big change. So that's what we are able to accomplish by deploying wise building in an old classroom building. Summary on the left-hand side, month of June, July, August, 3 summer months. Without the intervention, without wise building, it was consuming 8,340 kilowatt-hour for the 3 months. With the deployment, it consumed only 6,000 kilowatt-hours, so 27% savings by this control application. Now, different example. That was a classroom for heating, cooling. This is another office where we are deploying lighting control. In Arlington, Virginia, where I work, 5,000 square foot space, we provided 3 lighting controllers. Why 3? 3 areas which are different from each other. The first one you see is a storage area, workplace, ceiling lighting. It also has skylight coming in. On the upper right-hand side is the work area for the staff, ceiling light, and below that on the right-hand side is the conference room. You see something interesting. Nobody's around, lunch hour. Classroom is, conference room not occupied, staff has gone to lunch, but lighting is on, full capacity. This is interesting. On the middle picture, even though sun is shining bright, a lot of light coming in from the skylight, lights are still on full capacity. What we did, we deployed lighting controller, dimming controller, based on overall lighting and based on what you are doing right now. For example, this a space that in the middle has a lot of sunlight. We have a wall lighting sensor next to the window, you can see here on the left-hand side. As the sunshine increases, we dim the light automatically so that the total light, adding sunlight and the artificial light, is more than what you need. If you don't have any control, it's too much light. Similarly, on the upper right-hand side, staff has gone to lunch. Why keep the light on 100%? Don't do that. Maybe 50% is fine. Conference room, nobody's there. Why keep lights on? This is the cultural thing we have to make sure people understand. But doing this, we see the number. We're saving 33%, 34%, 35% every month. It's a big savings. So again, I give a summary here, month to month for 3 months now, October, November, December. Every month I'm saving 33%, 34%, 33.8%. Very good. What we did on the bottom part of the screen, the dimming level from 6:30 a.m. to 9:30 p.m. After that is turned off. Some office area 50%, some 45%, some 60%, depending on what they do in those areas at that time. Those numbers are not fixed. You can change it if you want to, depending on your usage pattern. So this is a benefit we see for lighting control using our WISE building platform. Next is solar. This is my building at Virginia Tech. I have put rooftop solar. So that is the data screen for the rooftop solar. We got on the top part, power, radiation, DC power, the AC power, panel efficiency, inverter efficiency, overall efficiency, DC voltage, DC current, AC voltage, power factor, all of that is there here. Point is, I am now able to give you full status of the rooftop solar using same WISE building platform that was used to get your lighting information and heating, cooling information. Next is battery storage. We put that in the same building you saw, which was 75-year-old building almost. 5 kilowatt, 12 kilowatt hour battery. You can see here, this battery is put on the wall in the garage, by the way, and getting data from everybody. Here is the data status. Again, same WISE building platform. Also shows me the battery status. Current status, active. It is charging. Output power negative, meaning it is almost fully charged. So nothing being sent out, only power being received. So that's it from my side. This is my email address, s.rahman@IEEE.org, my website, srahman.org. Many of my lectures that I've given last few months are on this website. If you go there, srahman.org, go to the presentation page, you'll find this. Again, some of you may know I'm running for IEEE President this year, 2021, and elections will happen or start in August. You'll get emails from IEEE for elections. Please keep that in mind as you vote in the election in August of this year. So I'm going to stop sharing now and go back to the screen so we can ask questions. Thank you very much.
Thank you, sir, for a wonderful and valuable and informative speech. Hope that it will be helpful for all the participants. Now, I am requesting the participants to please comment your questions in the comment box. Sir, during this period, I have also some questions of my own. I would like to ask you, Naim.
Sure.
So you know that there are so many buildings in Bangladesh. So how can we use our rooftops for solar energy? I think in Bangladesh it is mainly for solar system is very feasible for us. Other kind of renewable energy is not that much feasible like wind or IF. So how can you use our rooftops in this criteria? What is the suggestion?
Rooftop is very simple. In fact, I go to Dhaka very often. I've seen many multi-story apartment buildings have rooftop solar. So now there's a government program called net metering. If you sell power back to the grid, your meter goes backwards. I mean, you don't pay for as much as you used to pay before. So, and the price has come down significantly in Bangladesh and globally, in fact. So you can do some calculation. There are many companies in Dhaka and other parts of Bangladesh, Sylhet, Chittagong included, which have done solar applications. So what I would suggest, put the solar on the rooftop, no battery needed, connect the inverter to AC power back to the grid. And many companies in Bangladesh are doing this right now. Okay.
So do you think, sir, we have a question from Amimul Ihsan. How can you use the WISE building for the cooling of solar panels?
Right. WISE building is a platform to collect information and send signals to control. It is not providing any cooling function. You have to have air conditioner to cool the thing. You can control the air conditioner. So if you want to cool the solar panel, you can put a fan under the panel to cool it. The WISE building can control the fan. When the fan comes on, how long it runs, what temperature you should focus on. So all the hardware is not part of WISE building. WISE building is a platform to control. So cooling solar panels is possible using a fan so that WISE building can control the fan operation.
Okay, sir. Sir, I have another question that what kind of programming language should we learn in our undergraduate level in this kind of works?
That's a good question. The example I showed you was building is written in Python. It's Python language. And that's getting very popular globally. So I would strongly advise your students, undergrads, to learn Python and learn to program in Python. And if you go to my website, BEMOSS.org, we have the Python code available for WISE building in that website. Next question, can we operate WISE building in Bangladesh? Yes, you can, but then you talk to the company who's running it now in America, and then I can give you the company information. Write to me later on offline and contact the company. They can tell you how you can do it if you are able to. Yes. Yes, Sabir, go ahead.
Yes, sir. I think the lecture will be a little bit longer. No worries. Alhamdulillah, I have heard your lectures. Although I am from computer science background, but I was hearing your lectures very mindfully, and I just wondered that you have done a lot of things that people saying that we can do this, we can do that, but you have shown all the things you have done. It's really a great session that I have watched. Alhamdulillah. So we are really very happy to have you in this kind of session. We are trying to create research environment in Bangladesh. You know, the students of Bangladesh, they are fearing research. That is, how can they start? How can they can continue? How can they can publish in high impact journals, or how can they good in admission in good ranking or best ranking universities? These are the fears from the students of Bangladesh. So we are trying to remove fear from the heart of the students and trying to arrange different kind of free training workshops and webinar resource sharing to assist the research enthusiasts, new learners. So people like you are coming to this platform and and sharing your knowledge is really very appreciable. So thank you, sir. I think there is no more question. So Salman, Fazle, Rabby, can we finish or should we continue? Yeah.
I think I have a question because I am from electrical background. I would like to ask sir that this generation from electrical background or those who are studying, we say triple electrical and electronic engineering. They are saying that the power sector we cannot do more mass research. We are going to signal and system or biomedical system or machine learning, something like that. But after hearing this lecture, I am very much convinced that we have many things to do in power sector. So I would like to ask sir that to say some few words for Tripoli or all of the students, especially for undergrad students, because this platform is for them. Mr. Sabir has already told them that this group is for to remove the fear of research. So, do you have any motivating speech for us, especially for the students, those who want to do research?
Thank you. Yeah, power is a misunderstanding. I'm a power system professor. You see what I have done in sensors. So it doesn't limit you from expanding your horizon and do things. My focus in this research was to save electricity. It's my focus.
Yes.
How do you save it? Not by, I don't know, turning a nuclear power plant. That's not my business.
No.
I want to work with what is given to me. My building has a capacity, has a power supply. How can I provide same comfort, not make the building hot or too cold, same comfort using less electricity? So I'm showing you how to do real-time monitoring, and based on that information, you take some control actions. I showed you the lunchtime space. Nobody's there. The light is full capacity. Contrast survey is not being used. Light full capacity. That's standard practice everywhere. So we have put some intelligence, monitoring the occupancy level and the light intensity. Make smart decisions how to do this. So I would suggest the young generation undergrads, especially in your case, please keep your options open. Study, look at what's going on. Nowadays with Google, you can find many things, and maybe you can do a small lab at either your college in Sylhet or at 𝒉𝒂𝒃 to do building automation. In fact, some years back, the Bangladesh advisor for energy came to my lab in Virginia. He came, he saw this lab, BMOS lab, very impressed. So he has organized 𝒉𝒂𝒃 to build a lab like this. 𝒉𝒂𝒃 has a lab, BMOS lab now. The university has a lab like this. So 𝒉𝒂𝒃 can build a lab like this to show the students what can be done. And then maybe somebody will be interested. They will form a company to provide the service to commercial buildings in Bangladesh. That's how startups happen, all parts of the world. Okay?
So, okay. Thank you, sir, for a valuable time. Also, thanks to the audience for your participation. So, we have an ending announcement. To get updates of our activities, follow our page, join our group, and subscribe to our YouTube channel. We are happy to inform that we are now a family of more than 26,000 members, including group, page, and channel. Within this happened within 1 year only. Stay with 𝒂𝒂𝒂𝒏𝒈𝒔 𝑣researcher Bangladesh and invite your research enthusiast friends to our platform. Thank you for being with us. Wish you all success and good health. Thank you to all.
Okay.